I did not need to know that.
Should have said 5,400.
Yeah.
5,452.
It is climbing though. Okay, you're up.
All right. I think we are finally live. Thanks for waiting for us. I am going to start off with our CIMSS Tropical Cyclone page, and what you can tell is it is very, very busy. So, okay, I'm sorry. I also just heard myself. We will just, yeah. All right, over in the West Pack, we have Tropical Storm Barahat, as well as Super Typhoon Megahat, who I will touch on briefly. And then when we get to the East Pack, we have Tropical Storm Olivia, Tropical Depression Paul, another Invest. And then in the Atlantic, we have an Invest, Florence, Isaac, Helene, and another Invest. So yes, very busy. I'm going to start with Megahat, just because this is a very impressive system. This is currently a Category 5 on our scale. And if you can just see, I will get rid of the track right now in the forecast. We have a very well-defined eye, a very huge system. This made direct impact on Roldan about 2 days ago, and its current forecast has it going over Luzon Island in the Philippines. If I remember correctly, Luzon Island is very mountainous. So aside from the impacts of potential storm surge and then the winds, you could also look at devastating impacts from rainfall and mudslides. But taking that off, just looking at some of these surrounding environmental features from Megahat, we can see just very strong outflow at the upper levels, extending to the north, also extending off to the east. SSTs out ahead of it are fine, and ocean heat content out ahead of it is fine too. So there's nothing really, I'll just bring up the shear quickly as well, but it's in a favorable area of shear. There's nothing really that looks like could really decrease the intensity of the system as it heads towards Indonesia.
The MPI real quick.
Yes.
Right, I just want to show that this thing is really close.
Let me get this.
Potential of deep. What is it, 880 or something?
I think that's 880. Very difficult to tell. This is 900s. We're going to call that about 880.
So that takes into account the ocean heat content at the STs in the upper level to give you a max Mitchell intensity, and it's getting real close to that.
What is it? I missed that. What is it now?
Cat 5.
It's a Cat 5 right now.
What pressure? The depression. That was.
The pressure is currently.
It won't be listed there.
It won't be listed there. Never mind.
Well, you could do winds.
Yeah, you can just
149 knots right now. The MPI
150
knots.
150.
Gets to 180 knots.
Let's
So go backs are at 150 knots.
achieving.
Yeah, if you look at and wind, get rid of all of this stuff. And yeah, it looks like its MPI for wind is somewhere 160-ish. Let me just throw the track on there so I know. Yeah, somewhere between 160 and 180. So in theory, it'd go a little bit higher based on MPI. But it's on the West Pack. It's heading for Indonesia. All right, and then we're going to move on to Olivia. Olivia's made a comeback lately. It's still a tropical storm. It's actually still a weakening tropical storm. But a couple, even yesterday, like it would actually make landfall in the Hawaiian island has been forecasted. However, Olivia's got a little bit more convection here on the west side. I had an animated GIF. Don't know if it stopped. Let me see if I can bring this. See if we can bring this on. Yep, here you go. You can convective burst on the west side of Olivia. It looks like Olivia may actually make landfall in Hawaiian Islands after all. If you remember a couple weeks ago, we had in Lane, which could have made land, but Lane it really got sheared apart. Shear surrounding the islands and never landfall. We thought that could be the case with Olivia, but Olivia's gained a little bit at least convection and may actually make landfall. All right, and then we're going to head over to the Atlantic, which is why I'm guessing people are here. And let me find, here we go. This is Florence. This is the current satellite of Florence, and I also have tracked the track and the future track forecast on for Florence. One thing I first noticed is that it looks like Florence a bit to the right of track. Right now, it's basically been almost a mixture of CIMWF and GFS. They still can't seem to decide whether to a better agreement on where Florence will make landfall. Right now, still to the right of track on Florence. Florence is in a full area. If we get of the, let me get rid of the track on the forecast. Very favorable area of SSTs, a bit cooler along the coast, which may help diminish in intensity as it reaches the coast. And the ocean heat content is also reduced along the coast. One thing that they were doing with the aircraft yesterday, actually deploying buoys that would sense the water temperature ahead of Florence. It looks like they're actually maybe upwelling ahead of Florence that would not be seen on these maps. But the upwelling would be good in the sense would probably decrease density of Florence waters. I'm told to hold on,
People
but
are complaining that the audio is off.
people are complaining that it was off. So if that's the case, I'm sorry, but you can hear me.
You know if it's because there's two mics here.
What do you mean by off?
It's skipping. It's like a stuttering. There's a really bad stuttering.
Is this better?
Well,
Comments.
the one
Yeah,
in your
comment.
hand there plugged into the computer that has that on.
Yeah, this isn't picking up in, right?
It shouldn't be picking. I think John said he used this one. I'm sorry, everyone out there. Welcome to the first live stream tropical briefing of the year. Can someone write in the comments and let us know this is better?
I see it now. I think that's the answer to the comment.
Okay.
It seems to be a little like still skippy. I don't know. It costs that to let.
Hey, John, if you're listening, can you figure this out? John is our technical community person.
No settings on this one. What if we swap these?
I don't know what happens if you swap them. We have two mics for everyone who's not room, and we're trying to figure stuff out. Sorry. Yay, live stuff.
Let's try that. Not part of it. Probably not. It's the streaming side.
Yeah. Is this better?
We're not.
Never mind, I'm not in. So no, it's not better. Can you guys hear me now? Is this better? Area. If we get of the forecast.
Right now.
How's this?
Oh,
Can you guys hear me now? Is this better?
Okay.
Yay! Thank you, Derek, for figuring that out.
Second delay.
Yeah, we knew there was a delay. But it also reminded me, I never brought up the satellite image of Florence. So this has been good. All right, so this is the current satellite image of Florence. We can see a well-defined eye. This eye is not as clear as we've seen it in the past. And that could be related to potentially some weakening with Florence that I will talk about shortly. But you can still see the large expanse of Florence and starting to get the North Carolina coast up in the upper left of this image. So going back to Florence, I will just throw the track back on here so you get a kind of an idea. If you can make out this 4, this is where Florence is currently. Its forecast is head towards the North Carolina coast. Very favorable SSTs out in front of it. There is a slight decrease in SSTs. And for those of you who didn't hear, I was talking about the aircraft being, they're not quite drop zones, but they're more like buoys that will actually land in the water and they will actually to a certain depth in the ocean and measure of temperature. And one thing that they are noticing now is that even out ahead of Florence, we're starting some upwelling of colder water, and that could potentially also impact Florence intensity and weaken it a little bit. Just slightly hopeful there. All right, let's go back and look at the shear. I don't know if we've had a hard time analyzing the shear over Florence, or Florence is just not a very favorable environment. Some of this is probably from the upper level winds. We do see the upper level winds heading off, the outflow of Florence heading off to the north where we're seeing this high shear. But Florence is also in a region that's kind of stuck between 2 upper level anticyclones, and that could also be imparting some shear on Florence. And that could be one of the reasons we're seeing a weakening Florence.
MPI stuff over there, just comparing it to
all right, we've got a request to bring back up MP. Let me take off the shear. I will add, we're going to do the winds. So the MPI winds in here It's probably about the same. We're probably about 160, 170 knots. And Florence right now was last update at 10 a.m. Central Time was 115 knots, and that may actually have been updated. Let me find my tab. Go check quickly. Oh, the 2 p.m. update, so something that just came in 15 minutes ago, did reduce 110 knots. I still think that's a little bit, but I will talk about that later. Also, one thing we think Florence is potentially doing is undergoing an eyewall replacement cycle. So let me just see if there's any new, fingers crossed. Nope, there's no new microwave data. We haven't had a micro overpass of Florence in some of the main measures for 6 hours.
Never fails.
Yeah, it never fails when you want some. But if you look at this overpass from at B, you can see the ring of Florence here, but you can see portions of this outer ring. And what this outer ring could be an eyewall replacement cycle occurring in Florence. We also see it looks like the southern eyewall is entirely eroding.
That could be the shear effect.
Yeah, which
in the southwest.
Yeah, which could be a shear effect. If we go look at the Air Force C-130 aircraft observations from Florence, this is a mission that I believe they're actually on the way to completing. So you can see the entire C-130 track over Florence. I'm going to pull up the last leg of the track. And what we have here is we have mean sea level pressure in red, and then blue is the winds at the flight level. And so this was a leg that was going from south to north. And on the, here's our eye. And then so on the northern part of the lake, we have these two maximums in flight level winds. And this could be indicative of an eyewall replacement cycle. If we look over on this figure on the right, here we have the rain rate is in pink, and the blue is the estimated surface winds from a microwave radiometer. Yes, apparently that's correct. No one corrected me. And so it's estimating red means that there's too much rainfall. What this does is actually looks at wave action. And so it can estimate surface speeds based on the waves, the ocean. So red means much rain, and we can't use that. This wind mark here is maximum wind speed that it has on the northern wall. We expect the northern isle to be some of the maximum because this storm is heading to the west. So the north and west would be with storm motion. But that's even getting to 105 knots. Looks like Florence is weakening a little bit. It could be part of a replacement cycle. Could be due to shear. You know, the National Hurricane Center has still at 100 knots. I suspect that may be weakening, but I've also said that before and been entirely wrong. So maybe don't quote me on that.
I had to go in, like say this is shear, not ERC. Just there's so much asymmetry there, and you don't have ERCs at that level of symmetry.
Okay, so for those of us here, Jim Cosson does a lot of work with ERC. So go with what he says. He believes that a lot of this winning is with respect to shear and not an ERC because of the asymmetry.
Yeah, you can see the winds.
Oh, and how you can see here in the winds, like in the flight line and the surface, the southern eye wall is much weaker than the northern eye. So. All right, so before we get into the future track, I'll talk about a couple other storms, and I'm also going to go at past tracks, because if you were with us yesterday, you actually saw we had a large deviation in the track. So this is a track tendency for the American model, and it's looking at the past 6 forecast hours, so the day and a half. I'm going to refresh this and see if the recent one, no, but the one that started at around midnight last night. But what we can see is the darker it is, so the newer the fast track is. And yesterday, when we were giving briefing, there was a first large up where the GFS, the American model to the south. And lately, a lot of the forecasts have been hanging on to the getting right to the Carolina coast and then stop. If you look at the Ecmwf or the European model, the European model is also starting to agree with this abrupt just stop hanging out along the North Carolina coast. So we're looking into that in a little bit and see if that's happening in the newly updated models. And finally, I might actually just get that page, because we've been talking a lot lately. All right, so before we get into fast, I'm going to shift to Isaac. Isaac is a storm that is currently, here is Isaac, so it's a tropical storm. It is down and heading towards the Leeward Islands. One thing you will notice about Isaac, especially if you compare Florence, is it doesn't look nearly as decent as Florence. It's almost has an exposed low-level circulation, so it is a very weak tropical storm. But the models are doing some interesting stuff at that. It's still worth mentioning. First, let me go to see if I can find it. There it is. We're gonna look at Isaac. Like Isaac's looking a little bit ragged, and it's forecast to maintain its tropical storm intensity all the way through Leeward Islands. The STs out in front of it are not bad. It is definitely quite warm. You can definitely see some intensification there. But the issue that it's running into is now it's in a very unfavorable spot location of Shear. And we also have dry air in here. There is no dry air around there, so. But most of the forecast models, at least for the initial few days, have it maintaining its tropical storm strength as it heads through the Leeward Islands.
Sarah, real quick, do you have an animation running somewhere, a big GIF animation? No, running apps.
Maybe. I have these.
Any animation you have, you should kill.
All right, I will kill this. And I will kill this one.
Slow and things.
All right. Sorry, the satellite just high resolution. It was making stuff slow. This is a first one. When we brief this tomorrow, I hope be better. Fingers crossed. Yes, I didn't see that, but fingers crossed. All right, and so like I said, we have Isaac. We have Helene. Helene is fasted to pretty much go off to the north, so I'm not going to talk about it too much, except when I want to talk a little bit about this system, which is in the, we'll call it Minic. NH is currently given a 90% chance of development in the next days, and then 90% chance of development in the next 5 days. So pretty much it's going to develop. It'll probably up in the next 2 days. And then we have this system, which is 95L, which has a 6%. So in theory, in the next 2 days, Florence forecasted to make landfall for the next 3 or 4 days. Isaac should still maintain itself, have five systems in the Atlantic Ocean at one time. And has that ever happened before?
Sure.
Okay, it has happened before.
It's rare.
It's
very rare.
yeah, it has happened before, so it won't be history, but it is rare.
Oh yeah. 1995.
Apparently, 1995 is what I've been told. All right. So let's go ahead and start looking at the forecast. So I'm going to start the American model, the GFS model. We'll start back at 0Z. So here we have Florence, and then here is Isaac, and our other Investum is located right around here. Kind of see this little spin. That would probably be our system. But as we just through here, we're going every 6 hours. We're going to see Florence is maintaining its direct that heads toward the North Carolina coast until we get to the coast and we see this little. It makes landfall, but it just kind of stalls out on the east coast of Carolina. It's pretty consistent with what we've seen in the last couple models, maybe a bit farther inland, but then it almost just meanders along the coast for a couple of days. So the issue with this is that it could be a very prolonged rain event. I don't want to say a la Harvey from last year because that was an exceptional. I hope this is nowhere near a Harvey from last year, but it could be a very prolonged rain event. And Shane is going to talk in a bit about some flooding that we could see from Florence just because of all of this rain. And then as we keep going, eventually just goes up and down, or it goes down the Carolina coast before heading off to the north and then dissipating.
It's interesting to think that, I mean, we don't want landfall, but at least it causes the storm to weaken in a hurry.
Yeah.
Right, because it's moving over land. But here we've got a case where it's half over water and half over land installed. So.
Yeah, we were having a discussion on, is this better? It's like, so if it makes landfall, actually we have a discussion for this when it was just parked out. So when we were talking about the highest winds don't make landfall, but then you're under a prolonged set of winds. And so here, I mean, you may have the highest winds than not, or
I was thinking more freshwater flooding.
Yeah, a lot more freshwater flooding.
Loses water source.
Yeah.
So.
A la Harvey from last year, where it sat over Houston for 2 days.
I think it's going to be quite a stretch from Harvey, though.
Yeah.
Just looking at the QPF and even what's coming out of the GFS, it's about a sixth of the amount of precipitation, or even less than that, actually. So the amount of 20 inches of rain and greater is about 4,000 square miles just with the QPF. And with Harvey, it was about 8,000 square miles.
All right. So for those,
so there's a huge rainfall event, but that just kind of shows how much different that was.
Yeah. So if you couldn't hear that, the good news is that our flooding expert says the amount of rainfall associated with Florence compared to Harvey is not even close. Harvey had so much more precipitation potential with it.
But that doesn't lessen the.
That doesn't lessen the impact. It just may not be a Harvey.
It just means that Harvey was on such a scale that it's It's like,
Harvey was on a scale that we hope to never see it again.
Yeah. What about the winds? Like, there's going to be a lot of areas seemingly long residence times and like tropical storm and hurricanes.
In terms of building damage, that's a really not a really good scenario. Anytime a hurricane is skirting the coastline or over the water for a long period of time, it does, of course, it's working on the building and weakening it. And as the winds turn, the winds are maybe on the west side of the building for say 12 hours, and then now they're coming across on the other side of the building, and so that sort of dynamic helps to building over time. So.
Not to mention trees.
And trees.
Water.
And all the water coming in, right?
Let me ask you something. It's huge.
Yeah. One thing I am interested to see is to see the reaction of the residents going from more a social aspect of it is North Carolina had a devastating flood impact 2 years ago from Hurricane Matthew. They had about some places had up to 20 inches of rain from Hurricane Matthew. So residents, since they're for the most part, the wind event is going to be something that they probably haven't experienced before, but the rain event is something that a lot of them may have experienced. I mean, that was in October of 2016. So that'd be an interesting thing. I think Florence has a potential for more rain than Matthew did, but it's hitting an area where residents are at least aware of the potential damage that water can do, as opposed to hitting somewhere where they haven't experienced 20 inches, 25 inches of rain in a very long time. So I think that's why you're seeing more people taking the storm seriously, more people evacuating or or finding a safe spot, even if they're inland, because they know the potential of the flooding of the water. All right, so moving on to the ECMWF, I'm going to see if the new one is in, and if it is, I haven't looked at this yet, so this will be fun. Started the 0, yep, we should at least get through landfall. So here's the European model. It's just coming now, so this will be the first time I will see it. This is the location they have of Florence as of about 7 o'clock Central Time this morning. If we just step through, here we see a little bit of that same stall. So this is Florence moves a little bit in 24 hours and then run right down the coast. Kind of the same thing as the GFS just did. And then keeps skirting down the coast before eventually heading off.
A lot of them are doing that exact thing.
Is the pressure landfall in the model lower than what it is currently? The magnitude from maybe the signs of strength.
The pressure landfall, if we're calling this landfall, is about 2 millibars higher. So it initialized it at 950, which is a bit weak. We could also not be looking at full high res here. We could be looking at a res version. So that's why we wouldn't get the exact central pressure. But this right now would be a bit weak, and then it has it weakening slightly.
What's remarkable, I think, is the size, how big it is.
Yeah.
You remember earlier in the first discussion, I think it was on Monday that we had, it was just a little guy up there.
Yeah.
The radius of the winds wasn't that impressive, but it's really increased in size now. So you're going to get effects 200-300 miles away.
Yeah, and this is why if you look at the National Hurricane Center, and if we let's go to Florence, we can see they have hurricane warnings up from all the way the Virginia, North Carolina coast, all the way down through South Carolina. Even if this forecast holds and that it does make landfall and kind of skirts the coast, right now it's looking at landfall near the Wilmington area, but you're still seeing the effects of the wind and the rain, all the way through Cape Hatteras and up towards the Outer Banks.
So do all the forecasts now have that going? This morning it was all but the Canadian model, I think, were showing that.
Let's go to this is the UK Met model, and it doesn't have the same, like the abrupt stop on the then head south. We are seeing a lot of the curving here. And this is 0Z last night. Sorry.
What's stopping? I mean, 48 and 60 and 72 are within about
they have moved there.
30 miles.
If we want to look at, I want to look at Ecmwf.
Okay,
so that's not quite the same abrupt turn, but it's not moving much. Yeah, a lot of these models are now saying that it's not going to move very much.
Sarah, you know what's really going to be intriguing, I think, is where exactly it parked. If it parked 100 miles offshore over the Gulf Stream, I mean, it's probably deep, and the upwelling will be minimal because you're over the Gulf Stream. If it parks 50 miles closer to landfall, you'll get upwelling of the Gulf waters.
Yeah.
So there might be some effects there. So 50 miles could be a huge difference in what happens to this thing if it does slow down and park there.
If it parks over land, then it just pours everything on land for about 3 days.
On the comment of wind field expansion, I just looked it up, and the gales have expanded about 60 nautical miles since when it was a problem.
Okay. I'm trying to picture nautical miles and like how that relates to Carolina coast, but I don't know how long the coast is of Carolina.
It's gotten bigger.
Yeah, it's gotten bigger. The bottom line is it's gotten
radius
bigger.
has gotten 70 larger.
Yes.
Several miles larger.
So not the diameter, the radius.
Yeah,
So the diameter is 100.
Right.
Yeah.
Radius.
Yeah.
So presumably the forward speed and the amount of shear are correlated. So the slowdown in forward speed would be associated with a decrease in shear.
Not necessarily.
No.
No.
Say that again.
No, Chip, I don't think so. I rescinded Chip.
You don't want to say it again?
No, I don't want to.
No, we
You're
picked
on
up.
twice.
Yeah. The question may have been, okay. All right, so I do want to move on before we get to the flooding. I just want to talk about AL95, which is right off the Yucatan. This is one of the high-risk hurricane models, and AL95 is going to be right here in the middle as we step through. And right now, this has a 70% chance of development from the National Hurricane Center. And as we just keep stepping through, we can see right now we're finally at the Texas coast. It's pretty much has maintained its minimum pressure the entire time until here we kind of lose it, and then it finally is back here. So if this develops, like I said, mining is that it may not get. It may not get a name. I'm not just going to be that strong, but it's still going to be a major rain event for the Texas coast. They could be getting upwards of 5 to 8 inches of rain from the system. And then I just
goes back door. You're looking at Florence. Oh, by the way, here comes this thing into Texas.
Yeah.
And suddenly it's dumping 10, 20 inches of rain.
Kind of a forecaster's not quite worst nightmare, but one of those is just like I'm focused on one system, and the problem with this one, it could be all of a sudden then develops, and
forecasters will be on it. It's the media that might get behind this one, and then all of a sudden go, oh, you didn't tell us about that one.
Yeah.
Is there a good plot of forecast shear from some of the global models?
I just gotta figure out which.
If you go to a global, right there,
And
and
if
go
the
to
shear weakens when it's
upper level dynamics.
dynamics.
And here's your wind shear. Do you want this one?
So you want to look at the Gulf system in particular, or
No, for Florence.
for Florence?
For Florence.
Like as it moves in towards the Gulf Stream, towards the coast, what is
Alright.
the shear forecast to do?
Bear with us as this loads. Levi's site is amazing, but it's
Fortunately, they
been
don't
getting
have
hit a
the,
lot.
surface pressure on there. You can tell exactly.
Well, there's 950 written right here. There's 950 right here. So if we just step, it's hard to tell though. This year is just related outflow though.
Sure.
So, but if we want to look at the system down in the Yucatan, you see some of the shear related to, I believe this is the, here are the upper level cyclones, anticyclones. But it's kind of wrapping up. I didn't talk about Isaac. All right, sorry, I'm just going to jump back quickly because Isaac is interesting. We'll just go here. I'm focused on Florence. You just want to follow this system. I'm out.
Here's your size difference. So.
Yeah, here's your size difference. Here is Isaac. We're just going to keep following this out because this is the first time the GFS model has done It's just Isaac. I'm trying to just let the images load as I keep going. More recently, the GFS, the ECMWF, a lot of the models had been dissipating Isaac, or not, just maintaining tropical storm strike, not becoming very intense. Until the 12 GFS today, and Isaac is actually, it has Isaac gaining intensity. Here we're at 989, just south of Cuba, transversing Cuba.
It's not done.
It's not done yet, everyone. It's not done yet. It's not done yet. And if this can survive getting into the Gulf of Mexico, it could be a very strong system. Now, that's a big if. This is the first time we have seen any model do this. I'm going to jump to the ECMWF. I have not looked at this yet. I don't know what the ECMWF is doing with it. We're only out to 144 hours, which will not be nearly enough. But we'll give it a shot and just see.
Nope, 168.
Nope, and it's gone. And it's gone.
What's been keeping it down for the last couple of days? Has it been shear?
Isaac Shear.
Yeah.
And some dry air.
Yeah.
There's clearly some dry air on the north side of the circulation, and I think some of that dry air is wrapped around to the northwest side and into that air vector, which is being decoupled today. Combination of those two.
Let's see if you look at, can I bring up, can we see the dry air on here?
What?
You can see some dry air coming in,
Well, on the north side
and on the
there.
north side
Yeah.
too.
What about Florence? Yesterday it looked like there was some dry air. No, is it?
Florence has always had a little bit of dry air in its
Is that
environment,
happening?
and some of that sometimes works its way into the moat and gets kind of wrapped into the inner core at times. And I think
There's Florence.
It
it's
might
never
be
been a
dealing
beautiful
with it.
looking system, honestly, from satellite perspective.
Been
And it's-
dealing
Yeah.
with a little bit of that. Yeah, see that.
You can see some of that dry air
Yeah.
around it.
That's out there a ways.
It is out there
It's
a
gotta
ways,
get
yeah.
into the inner.
It's got to really
Yeah.
come in.
Yeah, every once in a while, some of it works its way in, but it's been mostly protected from that. But once the shear vector does increase a little bit, you might see if that's how
You see that right
Mhm.
now? Derek, remember you showed the MI image, or showed that
Mhm.
maybe it is.
Yeah, the south side of the circulation is definitely being eroded by maybe a
Yeah.
combination of shear and a little bit of dry air there.
Let's just see if something new came in on the microwave imagers. Nope, okay. It was worth a look. And then finally, this is the 90% chance of formation, probably from the National Hurricane Center. And so right now the forecast, this is Helene. So the GFS has Helene heading north, or this 96L heading south. We do see a very interesting interaction between the two.
Mhm.
We got a little Fujiwara effect going on before Helene heads off to the north. So right now, that is all that I have. I know Shane wanted to talk about some flooding,
I just had
so,
a couple skits short. So.
Yeah. Oh, that's okay. We've been doing this for over half an hour.
Yeah, it's really short. So there were questions about flooding yesterday, so I thought I'd bring up a few points. So
Shane, any chance you can make that bigger? For us, challenged.
well, I'm going to zoom in.
That's
All you
fine.
really need to do is see the colors
Okay.
for right now.
All right.
So the interesting thing about the river forecasting,
Right there.
sorry, the river forecasting, we don't need any more mic prop. The river forecasting is, generally speaking, the only 24-hour QPF is used for river forecasting. And so one of the reason a lot of these green indicates no chance of flooding within the forecast is because we're only accounting for 24 hours worth of precipitation. But you'll notice a few gauges here are showing this purple. And if we zoom in, this is one of those gauges. This is in North Carolina. This is on the Fear River, Cape Fear River. And you notice that we're forecasting potentially a record flood on this stream. And what's really interesting about this is this river forecast center, our river forecast center here in the Midwest, the North Central River Forecast Center, they've been doing what's called Ensemble Forecasts. They're using the PQPF to initialize their model with a 5% and 95th% precipitation changes out of the PPF. What they're doing here is slightly different that I wanted to point to. I talked to some colleagues, but they're actually using a number of different forecast models to look at precipitation differences, and then what the flood might look like based upon those different precipitation levels, and then that's what going into those two pages that are in this purple area right here is they're using the Ensemble Forecast to generate this. Let me go back and show you the one that's let's do the 7-day Chiefs here. So this is really helpful for decision makers. We can see this is our maximum river level that would be expected from the maximum potential precipitation. This would be the minimum that we would expect. And from an emergency management perspective, and this is the mean or median here, median river level. From emergency management perspective, we get the sense for kind of what's possible. What do we need to plan for? And in the North Central River Forecast Center, people are using this to help base this decisions on the evacuation.
Is that spread out pretty well? It seems a lot to me. Is that pretty normal?
That's not very normal. Okay. My experience in the North Central River Forecast Center's information that they provide, that's not normal. It's usually much tighter. Part of this could be because, we're 48 to 72 hours out from these crests happening. And so there's a lot more uncertainty in the forecast. So this is the storm surge page that NOAA maintains, and there's a lot of information on here. SLOSH, of course, is the model that's being used by emergency management community and NOAA to help forecast what we're going to have with respect to storm surge. And if you go to the Florence page, you'll be able to see this product that the Hurricane Center is putting together. And one of the interesting things that you'll notice, which is sometimes a little bit different than what you might find in the Gulf, is when you zoom in, and I'll try to bring this up so we can see a little closer, is that generally speaking, here where we're expecting landfall, we're not seeing a really high flood depth issue. And so I began to dig a little bit, but when you look at the surge potential, this is from SLOSH, looking at especially on the North Carolina coast, we're looking 11 to 15 to 16 feet in terms of storm surge. So why is there a big difference between what we're expecting here versus what the Hurricane Center is forecasting here? The reason is because along the North Carolina coast here, the elevation changes very quickly. So we have a sort of a floodplain along the coastline. We have a little bit of sandbars and sort of flat areas, but then as we go in very quickly, we'll gain elevation to 20, 30 feet. That's not the case as we go further south. So as we come further south, especially as we get into Georgia, we begin to lose that elevation change like we have in North Carolina. So as we come in here and as the hurricane and the forecast changes, I think you'll see some of the storm surges showing higher flood depths potentially as we get further south into South Carolina. And then if it makes it into Georgia.
Question from online here is how have these maps held up in terms of verification for past storms?
So I can't speak to these particular maps. I can speak to some of the maps that I've seen that were created by other means right before storm makes landfall. There's a lot of things that can happen locally that can change the elevation where you are. The bathymetry is one of those. What NOAA has been doing for SLOSH, after a lot of events, they use aircrafts to go out there and get the bathymetry very, very well. They've been doing that heavily for the past 8 years or so to capture that a lot better. Some of the old maps didn't capture the bathymetry very well. One case was Ivan. Ivan, the storm surge was forecasted to be maybe 6 or 7 feet lower than what they experienced all throughout that areas within Alabama there. And part of that was because they didn't have the bathymetry captured very well. And the other part of that was related to the forecast and understanding that it was weakening, but it was still maintaining the storm surge from hours beforehand. I think that's all.
So you're saying there's a lot of uncertainty in that forecast.
There's a lot of local uncertainty. There's a lot of local uncertainty in particular. Just small changes within the coastline can make big changes with respect to the storm surge. Big changes.
Jane, I see a lot of, this one is storm surge forced flooding. Then you have others that give you the precip and the associated flood. Is there any product that puts the two together on the coast and said, here's the combined effects of storm surge flooding plus the rain you're going to have in a swimming?
Nothing that I publicly. There might be companies trying to do that sort of. One of the big challenges in NOAA has, they're going to be doing stream forecasting on about 2,000 million streams in the United States with the National Water Model. One of the things they hope to capture something like that in the future. They're using, at one time they're using the University of Illinois for computing to be able to calculate those stream reach calculations. They're doing some of that internally. They're going through a lot of verification and validation to be able to do that. I think that's something you'll see in the future. I think they'll be combining what they're doing with their stream forecasting with what they're doing with the search. But it's just computationally so expensive to try to do both of those things.
And keep updating it every 6 hours.
Yeah, every 6 hours. I mean, I try to do that on my PC. By the time I'm finished, it's already old. You know, and the forecast has been changing so frequently. It makes it very, very difficult. So I think in the future, you'll see more of that being put together. All right.
Thanks, you guys.
All right.
Thanks, guys.
Okay, great.
Thank you. Thank you to everyone who stuck with us online.
Oh,
Yeah.